Now we have just two symbols more to talk about, and they are the implication symbols. So P implies Q. So the symbol is an arrow, and it means P in this case. P, because it's written first, implies Q because it's written next. It also means if P, then Q, and that's the translation that we'll be using most often. If P, then Q. So going back to our original example, P was it is raining, and Q was I am wet. Ooh, okay, let's see if we can get this down there. It is raining, I am wet. So P, if P, then Q means if it is raining, then I am wet. If it is raining, then I am wet. Now, this one can get a little tricky. Then I am wet. So we can definitely prove one of them falls right away. If we look at the second row, it's true that it's raining, but it's false that I am wet. In the second row, it's true that I'm raining, but it's false that I am wet. So the statement, if it is raining, then I am wet, cannot be true because there's proof right there that it's not true. It's raining, but I'm not wet. So that one is false. For a similar reason, in the first example, in the first row, it is raining and I am wet. So those both are true. So if it is raining, then I am wet is also true, because you have evidence to show that that is true. If it's raining, then I'm wet, because it is, and I am wet. Now the last two are a little weird. A lot of people have a hard time with these because they're a little weird, but the reasoning behind what we're going to say is the whole innocent until proven guilty. If you cannot prove something is a lie, you have to assume it's true. Innocent until proven guilty. So, how does this relate to anything? Let's talk about that right now. So in the third column and the fourth column, it's not raining. It's not raining here because it's false that it's raining. It's not raining there. So we have no idea what happens when it is raining. No idea whatsoever, since it's not raining. So therefore, if somebody tells you if it is raining, then I am wet, well, you have to assume that that person is innocent until proven guilty. You have to admit, you have to accept that that is probably true, unless you can prove it false. So the only thing that you can ever prove false is if you have true first and false second. TF is the only thing that can be proven as false. So that's the only implication that can be proven as false. So that is good to know. And remember, yes. Otherwise, saying we can break it down like that, or let's look at the trend. How can this be true? So if we looked at the very first two columns, the columns with P and as well as Q, how can it be true? If you notice here, when they were both true, the implication both ways was true. Also, when they were both false, the implication right here was also true. So to be true, for this to be true, P and Q must be the same. So if you don't want to go through all the rows, all the columns to get to that point, you can remember that for if and only if P, if and only if Q, for that to be true, then P and Q must be the same. So let's make sure we have this here, by the way. P, if, and only if Q. Those are the words that you use to translate this. So for P, if and only if Q to be true, P and Q must be the same. We can do this with a 3-proposition truth table, and it makes life so much more interesting because we're looking at a lot more. So let's do that. So we already have all of our first statements in, or first 3 propositions, and all the possible combinations of whether or not they can be true or false. So now we need to focus, in this case, on P and Q to fill out that column. So we're going to look here and here on P and Q, those columns. And since we're going in one direction, the arrow is going in one direction, if P then Q, they're all going to be true unless you have T first and F second. Tuna fish. So they're all true except TF. So we can even fill in those first. The falses, that's false. That's false because we have T first and F second. Same reason, we have T first and F second. And there's nowhere else that has T first and F second. So everything else in this case would then be true. Everything is true unless you have T first and F second. Now, it gets really interesting with all the arrows going all kinds of ways in the last one. So we have R right here, and we have if P then Q right here. And we're saying R if and only if P then Q. Lots of strange convoluted things going on there. But we can do this by looking at the columns that we need. So we need the R column, and we need the if P then Q column. And we need to recall that the if and only if symbol says to us that if they're the same, then it will be true. So the first one is true, true. They're the same, so it's true. And then, let's see, here it's false, false. They're the same, so that one is true. The one underneath is true, true, so that's true. And every other one is different. So false, true would be false because they're not the same. True, false would be false because they're not the same. False, true again is false because they're not the same. And I seem to have missed this one. They are the same. They're both true, so that's true. And this one is false because they're not the same. So that's how the implication works both ways. So for the arrow one way, they're all true except TF. All true except TF. And for the arrow both ways, they're true when they're the same.